All right, so here's where we're really starting our examples, okay? So here's where we're gonna need to use these steps. We're starting out, I've already factored everything for us, okay? We're gonna start with one like that so we can look at how to cancel everything once it's factored, okay? So we factored numerator and denominator. We're gonna now divide out common factors or cancel out the common factors, okay? Here's what you cannot do. You cannot just, oh, these b's cancel. No, this is b minus 2 and b minus 1. These are being subtracted. You can't cancel it unless you have another whole b minus 2 to cancel with it, okay? You can only cancel out things that are being multiplied or when you have that whole expression here and here. See, I have a b minus 2 here and a b minus 2 here. This b minus 2 is being multiplied by another binomial, so I can cancel these out, okay? Same here, this is b minus 1 and here's a b minus 1, so we can cancel them out. And then b plus 9 and b plus 9. So if everything cancels, you're left with 1, because b plus 9 over b plus 9 is 1. This equal to 1, this equal to 1. So 1 times 1 times 1 is just 1. Okay. All right, so here I just have an x minus 5 times 7 over x cubed minus 5x squared. Really, this is just over 1, right? Same thing. You can't just cancel out the 5s or just the x's because these aren't being multiplied together. You need to see exactly this expression, this binomial x minus 5, in order to cancel out with something else, okay? So what I need to do, this is simplified because there's not a GCF for 1 and 5 and they don't both have an x. 7 is simplified. So what I'm going to do is I'm going to factor, right? The numerator's factored, now we're going to factor the denominator. So I'm looking for a GCF, okay, for 1 and 5, and then I'll do the x's, and then for 3 x's and 2 x's. Well, the GCF for 1 and 5 is just 1, okay? Then they both have 2 x's in common, so we get an x squared. So what I'm going to do is I'm going to factor that out, meaning I'm going to take an x squared out of both of these terms. I'm going to factor it to the outside. So if I take an x cubed and divide it by my GCF, my x squared, 2 x's would cancel out 2 of the 3, leaving you just 1x. And then a negative 5x squared divided by my GCF, my x squared. Your x squareds cancel, leaving you just a minus 5, okay? I'm crossing this out because we've replaced it with this, right? This is its factored form. Now I have an x minus 5 on bottom and an x minus 5 on top that I can cancel out, okay? Leaving me just a 7 on top, a 1 and an x squared on bottom. So that means my answer is 7 and a 1x squared. All right, so step 1, factor numerator and denominator completely. This is factored, but it says squared, so I want to write out both of them. Squared means you have 2 of these things. So really I have x plus 2 times x plus 2. Canceling this out because I rewrote it factored above. 3x is factored, 2x squared you can't factor, it's just one term. X squared minus 4. If you remember, this is the difference of squares, 2 things that you could take the square root of. Okay, so you would have a squared minus b squared equals a minus b times a plus b. Okay, so I'm going to take the square root of both. Square root of x squared is x, and the square root of 4 is 2. So this would be my a minus b, and then a plus b. Okay, we've done this factoring before with special cases. So we get x minus 2 and x plus 2. cross that out because I've replaced it with its factored form. And now I'm going to see what would simplify. So I have an x plus 2 here and an x plus 2 here. This is x plus 2. It cannot cancel out with an x minus 2. As well as these 2's or these x's cannot cancel because this is a binomial, right? You can't cancel out just one of the terms in a binomial. You'd have to cancel out the whole thing. Here, my 3x and my 6x squared, this is just one term. This is just one term. I'm not adding or subtracting anything to it, so I can cancel out these things from each other. So 1x over an x squared, 1 and 1 would cancel, leaving you just 1 on the bottom. And then 3 over 6 would simplify to a 1/2. Okay, so what we have remaining is an x plus 2, a 1, a 2x, and an x minus 2. So that means on top I have a 1 times x plus 2, and on bottom I have a 2x times an x minus 2. So we want to multiply these together. So x plus 2 just stays x plus 2 on top, and then 2x distributed would be 2x times x is a 2x squared, and then a 2x times a negative 2 would give us a negative 4x. Okay, so we divided out or canceled out the common factors, and then the last step was to multiply the numerators together and then multiply the denominators together. And this is our final answer. All right, so this one, we need to factor most of them, and notice we have a trinomial now, okay? So, and this is what we're building up to. So let's go ahead and start with our trinomial, okay? I'm gonna draw my x, and I'm gonna label my a, see the side, yeah. A equals 1, B is 18, and C is 80. So 1 times C is 80, A times C is 80, 1 times 80 is 80, and then my B is 18. So if we listed out everything that multiplied to equal 80, you would have 16, yeah, and 8 times 10. So ones that add up to equal 18 would be 8 and 10. So we're going to rewrite this to be r plus 8 and r plus 10. Okay, my a was 1, so I didn't have to go back and divide anything. 2 plus 6, we're going to look for a GCF because we just have 2 terms. Okay, so I'll do right here. GCF, they don't both have an r, so I don't have to worry about that. But for 2 and 6, the only things that multiply to equal 2 is 1 times 2. Well, 2 will multiply by 3 to equal 6, so we have a GCF of 2. So we're going to factor a 2 out from each of those terms. So 2r divided by a GCF of 2 leaves us just an r. And then 16 divided by a GCF of 2 gives us 8. Okay. So I can already see I have an r plus 8 up top and an r plus 8 on the bottom. So I can go ahead and cancel both of those things out. Okay. And now let's look on the right side. I have an r plus 6. This can't be simplified because they don't have a GCF with 1 and 6. They don't both have an r. The bottom here, let's see if we have a GCF. Okay, so we have 9 and 54. And then we also have 3 r's and 2 r's. I can already see we have 2 r's in common. Oops, running off the page. 1 times 9 and 3 times 3 are the only things that multiply to be 9. So let's see if they have we want the greatest common factor. Okay, so these are the only common factors they could have. If 54 is divisible by 9, then that would be our greatest common factor. Well, 6 times 9 is 54, so our GCF would be 9. And then we have two r's in common, so r squared. So I'm going to factor out a 9r squared from both of these terms. So 9r cubed divided by my GCF of 9r squared. Your 9's cancel. 2 r's would cancel out 2 of the 3, leaving you just that 1. And then 54r squared divided by 9r squared. Your r squareds cancel. 54 divided by 9 is 6. Plus 6. So r plus 6 cancels out with r plus 6. I meant to scratch those out. Alright. So on top, I have an r plus 10. And on bottom, I have a 2 and a 9r squared. Okay. None of these can cancel out with each other, so that's what we get as our answer. R plus 10 over 2 times 9r squared is 18r squared. Alright, this will be my last example. So I have a trinomial, which means I want to use my x. So a is going to be 1, b is going to be 7, c is going to be 10. So a times c, 1 times 10 is 10, b is 7. So 1 times 10 or 2 times 5, the ones that would add up to give me a positive 7 would be 2 and 5. So this would be x plus 2 and x plus 5. I didn't have to divide these by my a because a was 1. The bottom, 3x plus 2, so I would look for my binomials to see if there's a GCF. So 3 and 2, the only things that multiply to be 3 is 1 times 3, 1 times 2. So GCF is just a 1. They don't both have an x, so I don't have to do anything with my GCF as 1. Here I have another trinomial, so we're going to do another x box. Notice our a is 3, which means we need to come back to that. B is negative 13 and C is negative 10. A times C, 3 times negative 10 is negative 30, and my B is negative 13. So you have 1 times 30, 2 times 15, 3 times 10, and 5 times 6. They need to multiply to be a negative 30, but then add up to be a negative 13. So a lot of y'all may want to say, oh, 3 and 10 is 13. But one of these has to be negative. So it's going to be our larger numbers in order to keep it negative when they add together. 3 and a negative 10 would actually be a negative 7. But we have 2 and a negative 15, which would make a negative 13. Okay, so just be careful with that. I'm going to write it off to the side because I have x plus 2 and x minus 15, but my a is 3, which means I need to go back and divide each term, each of those by 3. If it can't simplify, then that 3 slides in front to be 3x plus 2. And then if it does simplify, you get x minus 5. So we're going to rewrite this to be 3x plus 2 and x minus 5. Okay? Now it's a lot of factoring on this one. All right, and then this bottom one, 2 terms, so we're just going to look for a GCF. So for 3 and 6, and then this one has 2 x's and this one has 1 x, which means they have 1 x in common. 1 times 3, well, this one's also divisible by 3. 2 times 3 is 6, so their GCF is going to be 3x. So we're going to factor that 3x out of both of these terms. So if I do, yeah, y'all can see this, 3x squared divided by my GCF, which is 3x. 3's cancel. One of these x's would cancel out one of the 2, leaving me just a 1x on top. And then 6x divided by my GCF of 3x. 6 divided by 3 is 2. Okay, so now we've done step 1 Took a little while, but we did step 1. We factored the numerator completely and the denominator completely. So now we want to divide out common factors or cancel out the common factors. Okay, so 3x plus 2 does not cancel out with an x plus 2. Okay, you'd have to cancel out that whole thing. Like here, I have a 3x plus 2 and a 3x plus 2. So I can cancel those out. Okay, here I have an x plus 2 and an x plus 2, so I can cancel those out. All that's left on the bottom is a 3x. That doesn't cancel out with either of these. So I'm left with these on top and this on bottom. So I get an x plus 5 times an x minus 5 over a 3x. We need to actually multiply the whole thing out, not just write them being multiplied out. So x plus 5 times x minus 5. We're going to do the box. Okay, x times x is an x squared. Negative 5 times x is a negative 5x. 5 times x is 5x. And 5 times the negative 5 is negative 25. Like terms on that diagonal, 5x's minus 5x's mean they cancel out. So you just end up with an x squared minus 25 on top, and then your 3x on the bottom. That's it.